Okay, we already have over 200 people on the webinar, which is absolutely fantastic. So I'll give it a start. Welcome to this webinar from the IET Central London Network. We're a group of volunteers working with the IET, the Institution of Engineering Technology. We put on monthly events of general interest to engineers and anybody else. And this is our November Wednesday or monthly evening lecture. My name is David Tabor. I'm the chair of the IET volunteer area for Central London, and it's a great pleasure to introduce this meeting. On the agenda tonight, as you can see on the slide, Roger Bailey, the Chief Technical Officer of Tideway, will give us a talk on the Thames Tideway Tunnel for about 40 minutes, after which we'll have plenty of time for questions and answers. When you do have any questions, please use the Q&A button that you should find at the bottom of your screen, or maybe the top, and type in any questions you have. My colleague Ramesh Patel will be monitoring that, and will be, at the end of the talk, he'll feed those through to Roger for his responses. Please do not use the chat function, because that will just confuse us. There are CPD points available for attending this lecture. 1 hour is available. So if you need the form, I will be posting the link to a downloadable form in the chat towards the end, and there's also the link in the closing slides, so you'll see that. So let me introduce our speaker for this evening. Roger Bailey is the Chief Technical Officer of Tideway. He's a fellow of the Institution of Civil Engineers, so we won't hold that against him. And he's held board-level positions in engineering and contracting businesses over many years. So I'll now pass control over to Roger, and he will share his screen.
Okay, thank you very much. Thank you, David, and thank you everybody for joining this evening. Look forward to answering your questions later on. So I'm going to canter you through a lot of information. Here goes an overview of where we are on the Thames Tideway Tunnel project. So our challenge is to build a new sewer for London to prevent the frequent pollution of the River Thames. But our vision is not just to clean up the Thames, but to promote a change in the relationship between London and Londoners and their river. And also, given the size of our project, its impact both in London and on sort of the wider construction industry, to really leave a lasting legacy for the future and build on the great work done by other projects that have come before us. So just a bit of a history lesson. If you go back to the Victorian era, these are the tributaries of the river. They're largely called the lost rivers now, the hidden rivers of London. Rivers like the Fleet, the Tyburn, they have largely been covered over, because in the Victorian era, as the city expanded, so they got covered in and used as open sewers by the population. Those of you may be aware, in 1858, something called the Great Stink happened, where the river got so polluted with sewage that the parliamentarians were sort of in fear of their lives from the miasma, which was the smell, or what they thought the cholera was passed through the air, through the miasma, so they got quite upset, and they allowed Sir Joseph Bazalgette the money to solve the problem, which in those days meant putting in a whole series of sewers across London, high, middle and low on the north side, and a similar system on the south side. These sewers intercepted the old culverted tributaries of the Thames, like the Fleet, the Tyburn, the Westbourne. They intercepted them, and then through a series of pumping stations the flows were taken to the east, and here at Abbey Mills, just south of where the Olympic Park is, a cathedral of sewage, a massive pumping station, pumped the sewage up 20 or 30 feet into the northern outfall sewer, which and then discharged into a whole series of open tanks here at Acton. There was no sewage treatment works back then. That came later. And a similar situation on the south of the river, and that ended up at Crossness, just off the map here. So Sir Joseph Bazalgette's system is now well over 150 years old. It's done it's done a superb job, but because the system in London is largely a combined sewer system, so that means that flows from people's toilets and rainfall runoff onto streets in large parts of central London goes into the same pipe system, and then it goes into these sewers, these trunk sewers. And what therefore happens is in the normal diurnal flow, there's a peak of flows in the sewers in the morning. There's a peak in the evening, and then when it rains, that peak can be significantly exceeded, and you can find from time to time the system will effectively reach its capacity. And when it reaches capacity, it overflows into the river. I'll show you in a second what that is. But typically, for the at the moment, before the improvements that we are making have happened, because as little as 2 millimeters of rain can now cause the system to overflow, because the population of London is now significantly greater than it was back in the Victorian times, we get very large overflows into the river. Now, this is a picture this is the Fleet River. This is looking sort of south. In the background, you can see big flat valves that open out into the Thames. And actually the Districts and Circle line runs through this as well. So it's a very congested area. This is near Blackfriars Bridge. This is fantastic Victorian infrastructure that, as you can see, is in amazingly good condition, considering it's 150 odd years old. The workmanship and the durability is quite incredible. However, it's reached its capacity. So Joseph Bazalgette designed the system when there were 2 million people living in London, but he designed it for double that, 4 million. In 2019, there's just under 9 million people living in London, and it's projected to be over 16 million, almost doubling in another 150 years' time. And what's happened now is that when we get these extra flows into the river from rainfall, it overflows through flat valves in the river, and this is one of them. This is a combined sewer overflow at the River Effra, which is just under Vauxhall Bridge on the south side of the bridge, quite close to the MI6 building, and that's what happens sort of 50 times a year. And in a typical year, up and down the tidal Thames, something like 40 million tons or 40 million cubic meters of sewage, raw and storm sewage, comes out into the river, causing all sorts of pollution in terms of the reduction in oxygen, obviously litter, ecological harm as well. So back in 2004, in the summer, there was some significant overflows into the river. 500,000 fish died, and whatever Londoners put into their toilets, and believe you, they do put some strange things in their toilet, it all comes out in a storm into the river. And if you go to certain parts of the river where it deposits, like at the bottom of the Isle of Dogs, you can see enormous quantities of sort of sewage-derived litter that are coming out onto the foreshore. And just to sort of put something in your mind, for those of you who've been to Wembley Stadium, if you filled up Wembley Stadium, the bowl of Wembley Stadium, like a giant toilet bowl, with sewage, that would be about 1 million tons or 1 million cubic meters. So in a typical year, 40 times Wembley Stadium's worth of sewage is going into the Thames. Back in 2014, when we had those of you remember, we had a lot of rainfall in the London area, in the Thames catchment. 65 million tons of sewage went into the river in that year. Had all of these improvements I'm about to sort of go through with you been in place, but at that time it would have been about 2.5 million. So our system and the other upgrades that have been done are not going to eliminate this problem. That would be grotesquely expensive and pretty much unnecessary, because 2.5 million tons of sewage into the river, generally, if it goes in small sort of units over time, is not going to cause an enormous problem ecologically. So what is the solution? Well, it's the London Tideway Improvements. It's a three-pronged program. Firstly, if you're going to capture this sewage that's going into the river, then you need to treat it. So the first thing is the upgrade of 5 big sewage treatment works in the London area. That was done by Thames Water, back in about between 5 and 10 years ago. So they were all upgraded by about 50%. Then Thames Water built the Lee Tunnel, which is a very deep tunnel running from Beckton up to Abbey Mills. It is effectively the eastern and the lower end of the overall system. So those works together were probably about £1.5 billion collectively. They were done by Thames Water, and they were done as part of its normal regulated asset improvements that they did as a regulated water company. The Tideway is a separate company, and that's because as Thames was involved in looking at this problem with the government back in 2007, they were increasingly concerned the size of this project. It's, you know, our cost is £4 billion. The size of that compared to Thames's asset base was enormous. The risks of tunnelling through London, etc., and Thames were not keen to take it on board on their own balance sheet. And they agreed with the government that the best way forward was to create a special purpose vehicle, which Thames effectively created, promoted, but then it was then as part of the whole process of the delivery model, which I'll explain later, that then became taken over by a new group of investors, which is going to see it through the delivery phase and into its long-term operation. So that then finished the piece off with the Thames Tideway Tunnel, which is the 25-kilometre deep, very deep tunnel from Acton to Abbey Mills, linking up with the back of the Lee Tunnel at Abbey Mills. This shows a little bit more detail the project. Here is Acton. At that point, the tunnel is about 30 metres deep, and then it flows underneath most of the subterranean infrastructure of London down to Abbey Mills, where it goes into the Lee Tunnel and then on to Beckton. We've got 2 subsidiary tunnels, a smaller tunnel here, which picks up flows in the Wandsworth area, and a slightly larger 5-metre tunnel here, which picks up flows from the Greenwich and the southeast London area. We are building the project in three sort of sections: the west section, central section, and east section. And I'll show you those contractors in a minute. So we have 3 large contracting joint ventures building the project for us, and a system integrator contractor, which is putting in all of the telemetry and the control systems to control the overall system. And the overall system will include the Thames Tideway Tunnel, which we're building and owning, plus the Lee Tunnel, which Thames Water own. And so the overall system that we're bringing into operation is the London Tideway Tunnels. And that will be jointly, if you like, controlled by Thames Water and Tideway. Just a few facts and figures here. So as I said, it's 31 to 66 metres deep. It's 7.2 meters wide, the main tunnel. It flows pretty much at about 1 in 800 from Acton in the west all the way down to Beckton, and that's self-cleansing. We don't expect the tunnel to silt up, because that gradient will ensure that material is taken down through the tunnel. It will hold 1.6 million tons of sewage in capacity, and that will capture, some pretty much the biggest storms that generally hit London. But if there is a back-to-back storm, very large back-to-back storm, before the tunnel is pumped out, and it will take the tunnel is pumped out at the Tideway pumping station, which is down at the Beckton sewage treatment works. It's already been built by Thames Water. 6 very large pumps in there that have already been commissioned and working, and it will pump out the total amount of 1.6 in about 1 to 2 days. The cost will be 4.1 billion. That's the cost to Tideway, and that translates to a cost for the bill payers in the Thames Water region of between 20 and 25 pounds per sort of household per annum, and we're 25 kilometres long. That's some of the facts, and just sort of how does this thing work. So this is right outside the IET building on the Victoria Embankment. This is our Victoria Embankment site. Obviously the London Eye over here. Here is Sir Joseph Bazalgette's low-level sewer. Here is the District of Circle line, which he put in when all of this was reclaimed. So we have created a hole through here into the river, through the river wall, or we will be creating a hole into this low-level sewer, creating a weir. The weir, when the storm comes and fills this up, it will overflow out into the culvert here, down through a vortex generator, which allows it to safely drop through. I think here it's about sort of 40 or 50 meters into a stilling basin, where the air comes out of it, that's entrained as it falls through here, through a gap here, and then into a connection tunnel, and then into the main tunnel, and it goes off down Beckton, where it's pumped out and into the sewage treatment works. A huge amount of work's been done on the hydraulics of this structure. For those of you who would like to go onto YouTube, go to Sewer Geyser in USA, you'll see what we are trying to avoid here in central London. If you get air entrained into the tunnel at depth and then forming pockets, obviously that air wants to come out, and if it'll move to come out at the first point. And if this shaft here is very narrow and full of sewage, full of liquid, then that will come out at the top through any gratings or holes it can find, with some quite dramatic consequences. So our system has been designed so that the size of these shafts is often dictated by making sure that when any air pockets that would be caught in here come out, they just harmlessly vent into this space. We've also got very significant sort of amount of hydraulic modelling that's been done, computerized and with models in various institutions around the world, to make sure that these structures work accordingly and you don't get silt build up in areas, etc. So there's quite a lot of good innovative work that's been done to optimize these designs going forward. But that's a typical situation, and we've got similar situation to this up and down the river. One thing you will note, of course, is that this is in the River Thames. So we have 21 sites across London, and 7 or 8 of our sites are actually in the River Thames, and they're creating new pieces of London, new pieces of public realm, of which this is probably one of the most dramatic, right in the centre of London. And Blackfriars, which I'll show you a bit later on, is probably the largest a bit further up the river or further down the river from where your offices are. This is a vortex generator tube. It's just been installed at the Hammersmith site. This is the liner, which is a stainless steel liner. That's the vortex generator where the flows come in. They're then sort of accelerated and they come through this tube. And that's a picture taken from the base of the shaft, looking up as we make progress and install this equipment across London. We're tunneling through London. Our contracts were set up, the west, central and east contract was set up largely to sort of align with the underlying geology. So in the west, we're in London clay. Our tunnel boring machine went through the shaft down through the shaft at Fulham, and then tunneled up towards Acton, and it's arrived there a month or two ago. We then, our main drive site, one of the sort of apex of our project, Kirtley Street by Battersea Power Station, we have 2 tunnel boring machines. One started 2 or 3 years ago, and that has finished, and that's finished the drive to Fulham. That's in this section here is in sort of mixed ground, and the second tunnel boring machine from Kirtley Street is about to reach Chambers Wharf in Bermondsey, and just gone past and under Tower Bridge a couple of weeks ago. And in the east, we're into chalk. So it was clay in the west, chalk in the east, when you get down to these depths, and in the middle, a mixture of the clays and the sands and gravels, which is generally more challenging for tunneling. Tunnel boring machines are the type that we're using do like to go through homogeneous ground. So we've got that in the east and the west, and it's been a bit more challenging, but we've successfully completed it pretty much completed it through the central section. So we have a west contract, central contract, and an east contract, so that the ground conditions generally are relatively similar for those sections of tunneling. So our timeline, the government initiated the project back in 2007. Planning permission was obtained, the development consent order back in 2014. Construction contracts were awarded in 2015. Our enabling works began in 2016 as some significant enabling works on the project. Tunneling commenced in 2018 and will end in about 18 months' time or so. And then we'll start system commissioning and handover. So Thames Water is the operator of the system. Tideway will design and build it, and it will hand over operation to Thames Water, but we will retain ownership of the deep assets of the project, sort of ad infinitum, basically, as long as we have a license as a licensed water company. So it's very much a partnership between ourselves and Thames Water, and also with the government, as you'll see shortly. So our delivery model, Tideway, official name is Bazelgette Tunnel Limited. I'll go through the ownership on the next slide. We have around about a third of the capital cost is through equity, the remainder is through debt. Some of that debt is very interesting because we've been one of the biggest raisers of money through the green bond market worldwide. And that's a great story for us, because we've been able to attract that investment because we are an environmentally sustainable project, but also because a lot of the ways of us going about our project and the way that we're building it is also environmentally sustainable. There is a government support package, so we've paid the government effectively a sort of insurance policy, so that in the event of certain things happening, like not being able to get insurance in the London market, like not being able to raise funds because of a breakdown in the financial markets, that the government would step in, and it's pretty much almost inconceivable that government support package will be drawn upon, that it is there, and because it's there, and because there is a small potential theoretical likelihood of it being drawn upon, the government has to make sure that we are undertaking the project in the correct manner. So it's a true private public partnership. Every quarter we have to report through to what's called the liaison committee, where Ofwat, the regulator, representatives of the government, and obviously Thames Water are all present, where we have to go through our progress of the project and subject to that scrutiny. Bazelgette Tunnel is the official name of Tideway, so we're trading as Tideway. Jacobs is our program manager, and Jacobs manages the three contracts that we have with our mainworks contractor and with Amy, which is the system integrator contractor. So in the west, we've got BMB, which is Bam Nuttall, Morgan Sindall, and Balfour Beatty. In centre, we have Ferrovial, Agraman, and Lang O'Rourke. And in the east, we have Costain, Volsey, and Bassy Solitage. And the system integrator contractor is Amy. So our shareholders are Allianz, who you'll be familiar with, a very large European insurance and financial organisation, DIF, which is a Dutch infrastructure fund, and Dalmore Capital and Amber Infrastructure, which are British asset owners and investors in infrastructure across the infrastructure sector. So those are the shareholders. The interesting thing about the shareholders is they all have a very large pension investment sort of stake, and that's how they do their business. And so they are shareholders that are taking a very long-term view of their holdings and infrastructure generally, which is good, because our project, it has a design life of 120 years, which, as those of you who know about these things will know, that means that at 120 years, it's not crumbling to dust. It means that it's still doing the job that it was designed to do at 120 years. And really, with good maintenance and sort of proper inspection, it should last, hundreds of years going forward. So it is a truly long-term investment. One thing that's very, very important to us is leaving a legacy, and we have a number of commitments that are enshrined in our planning permission and our development consent order across these sort of key areas. Obviously, we are an environmental project, so cleaning up the river is core to us, but also doing it in a way that is environmentally friendly, with a low carbon footprint, and things that are going to improve the environment, particularly things like air quality in London, a very important aspect to us. Health, safety, and well-being. I remember back in 2012 when I first came to the project, one of my jobs at the beginning then was to sort of look at our health and safety strategy, and I worked out we had sort of 19,000 person years of employment to build this project. And if we were good in terms of British infrastructure project health and safety performance, then we could expect, even as a good performance, to have something like 3,000 people have to go to A&E or have sort of serious first aid, 200 people to have sort of life affecting occupational health impacts, like sort of sight, respiratory, hearing, musculoskeletal, that sort of thing. 150 serious injuries under RIDDOR, sort of the HSE definition, and shockingly 2 fatalities. So that was if we were good. So really, we came to the conclusion that good really wasn't good enough. We couldn't expect to get that. So we started off right from 2012 having a transformational approach to health and safety, and we got the support of Ofwat, we got the support of the government, sort of Thames Water to that. And you know, we're not complacent, but we're here now 60% through the project, 21 million person hours of work that we've done, and we have had accidents, and some of them have been serious, but we don't believe that anybody has had a really truly life-changing injuries on Tideway, and thank goodness we haven't had any fatalities. But we're absolutely not complacent about this. We've still got a long way to go. We've still got 2 tunnel boring machines to start. But one of the things we did do is we set up a proper induction centre, a really impactful induction centre. This is a picture of it, and it's a whole day where individuals in batches of 30 come to a purpose-made centre in central London, where they experience the horror of a fatality happening in a simulated way, and then how that plays out with the person's colleagues, family, etc. At the same time, in the middle of that day, members of the senior leadership team, myself, the chief executive, and others, it's about 8 or 9 of us, we come along and we meet the people on that particular day. We shake their hands in normal circumstances, and we explain to them how we do things here safely or not at all on Tideway. And I think it's because of that commitment of the time. It's not death by PowerPoint. It is very impactful. We've won lots of awards for this, and everybody, every single person who works on our site has to go through this day. And even the drivers who are delivering materials to our sites have to go through this, and all of the boat masters who are moving our materials on the river. And it is one of the key things that we're trying to get this facility to be used more widely by the construction industry at the end of our project. So, and we have other legacy aims in the economy, mostly about the river and on place, because we are creating all these areas of public realm in parks and on the foreshore. And we also recognise the amount of people that we are employing, and we have a real obligation to make some changes there. So we've also been a big supporter of Mates in Mind, which is the construction industry mental health charity. I'm sure many of you are aware of the prevalence of suicide and other mental health issues in the construction industry because of the nature of the construction industry. And we've been a big supporter of them, and we've also made sure that we're encouraging people on our sites and in our management team to take up the mantle of being mental health first aiders. I'm a mental health first aider, chief executive is, and a large number of our team are, and it really has changed dramatically, I think, the awareness, understanding of these issues, and the ability of people to talk through their issues and to make sure that they don't develop into something more serious. One key thing about the economies of the river in particular, because of our projects, about 8 million tons of material is needed to be brought in and taken out. Muck coming out of the tunnel boring machines, tunnel segments, and concrete coming in. If we had used all by road solution, 500,000 vehicles would have been used on the project. Obviously, the project is along the river, so we used the river for our logistics significantly. We built a lot of wharves and jetties along the river, and that's been part of the enormous amount of enabling works that we've had to do. As a result of that, we have reduced the amount of vehicles significantly down to sort of something between 100 and 150,000. That's great news for London. It's great news for the residents around some of our sites, which are in residential areas. And you know, we've delivered on that. However, the problem was that by putting so much logistics onto the river, we were stretching the river sector, the marine freight sector in London dramatically. And we were very concerned then that whilst we were moving a risk off the roads and onto the river, we were creating another risk on the river. So that was one of the things that we then did was to invest significantly in a couple of things. Firstly, we wrote a new code of practice for the river, which didn't bring in new requirements, but it made them much more clear about compliance to those requirements. We specified that all freight on the river working for us had to be compliant with the International Safety Management Code, which it wasn't. The code existed, but it wasn't required for freight on the River Thames. And the River Thames is quite a unique river. You know the tidal range of it, the bridges, a lot of traffic for recreational sort of leisure up in the Putney area and in other areas, and obviously the tourist traffic plus freight traffic as well. And we were very concerned about the standard of training on the river. So what we created up in the HR Wallingford, the Ship Simulation Centre, was a digital version of the River Thames. This is my boss, Andy Mitchell, trying it out a few years ago. Every single boatmaster and mate who works on Tideway goes up there and spends between 2 and 4 days in a combination of being trained and also being assessed for competency, and often it's more attitude. And we've put something like 70 or 80 people through this, and it's been a massive success. And not only has it given us the confidence that the people working on our sites are of the right competence, but also it's helped them to improve their competence. We had to do this because when we started, we were increasing freight on the river by 2 or 3 times at the peak of our operations compared to the underlying level. So we were concerned that we would cause problems on the river by the sheer volume of the work that's been done. I'm pleased to say at the peak of our river activity happened sort of around about September of 2019, and we've still got quite a way to go. We'll still be moving stuff on the river till the middle of next year, and then we'll be taking lots of materials out when we finish. But we've done it so far in a good way. We're very happy with the outcome so far. With yes, we've had incidents, but they haven't been a lot of them, and they haven't been major. And Thames Skills Academy is an organisation that we've been supporting, which is providing training for this sector on the river. Apprentices on the people side, 1 in 50 people working on the project has to be an apprentice, and these are some of them with our chairman a few years ago on site, and we stuck this requirement in our contracts, and we've followed through on that, and it's been very successful. And we've got a lot of young people and older people out on the job. We've also are pioneering. This is the first cohort of women returners or returners came onto the project a few years ago. We've had 3 cohorts. Some of these are ladies, pretty much mostly ladies who've taken a career break, mostly to have a family. Some of those career breaks up to 20 years. And I know how difficult it is coming back to work after 2 weeks holiday, but after 20 years is pretty dramatic. And people who are doing that need an awful lot of help, I think, to successfully get back into the working life, the new systems that are there. So it's not an easy situation. We brought these ladies in for 12 weeks, and then all as a sort of initial period, and then they all of them got further jobs and with us up probably for at least 2 or 3 years, and some of them are still with us now several years after this, and it's been a real success for us because one of our aims is to get to Tideway as a company having 50-50 male-female participation. We've got to about 36%, which is great. It's very, very difficult in a technical organisation like ours to get to 50%. We're still trying, but this was one of the things that was really helpful, to bring new people who probably were finding it really difficult to get back into employment. So these are some of the extra miles we've done. We also through our Encompass inclusivity program, we've been looking at how we can be a great employer across the gender side, the LGBT side, in terms of cultures and ethnicities, and in terms of disability, and really going the extra mile to make sure that whatever background people are from, that they feel welcome, they feel comfortable, they feel they can be themselves when they come to Tideway. We've made a real effort to do this, and we've been fortunate in getting great sort of support from our workforce, and great engagement scores, and also a lot of external awards. We require our contractors to, as part of their contracts, to engage in volunteering in STEM activities. We've had something like almost 40,000 hours of volunteering over the last few years. I think about 11,000 of that is STEM activities like this, people going into schools and going through with students what we're doing, and explaining to them how it relates to them, and really making a difference across London, as well as sort of more sort of conventional volunteering and engaging to get people out onto the river, to get people doing more activities related to the river, and to get out there and volunteer to do things like Thames River Watch for charities like Thames 21, and other activities to sort of to help to sort of in this case it was helping the riverbanks from erosion caused by Japanese bitten crabs. Right, how are we doing for time? I'm going to try and complete now with a sort of up-to-date sort of where we are on the project. So I wanted to focus a little bit on Blackfriars because there's some great engineering that's been going on, and it's a real shame in a way that because of the lockdown we haven't been able to celebrate this as much as we would have done in normal times. But here at Blackfriars, just downriver from where you are, we've got sort of one of our most challenging sites. Here's our tunnel, the main tunnel. Here's the Bazelgette's older low-level 1 sewer. Behind it is the District and Circle line running under the road. Here's the Waterloo and City line, about 5 or 6 meters underneath our culvert, which comes down from, that is the opening you see there is the River Fleet, where you saw that chap earlier on in the sewer. That was the other side of that opening. This is all new structure, that the yellow that we're building, and it links in through a weir structure here into low level 1, and through this structure here into the main into the Fleet River, and then the flows come down here, and then you can just about see the tops of the vortex generator tubes here going down into the shaft, and this is the air treatment unit with the vent columns here, and here is the new CSO that we'll be providing. At the moment, the flows come out of the Fleet underneath Blackfriars Bridge. When all this is completed, they'll come out here in a new overflow in this structure. So this is one of the most complicated pieces of civil engineering on our project. We've got, as you can see here, a number of cofferdams. This is for the shaft. This is for the culvert works. And over the last few years, this has been going on in central London. And the building of this culvert here, this is effectively a dry dock, and inside there is being built what we call the floating culvert. This section of works coming out underneath the bridge has been built in a dry dock and was floated out on the August bank holiday weekend underneath the bridge in a pretty unique operation. The cofferdam will then be sealed up and all those civil engineering works completed. And then this is the 1.5 acres of public realm together with some amazing sculptures, the black stages, which will create a truly amazing sort of location and destination for London. So it's great because there's a huge amount of civil engineering going on underneath the surface, but there's also going to be this great public realm for people to enjoy. And the views are going to be incredible. That's the view back to central London, and an equally amazing view to St Paul's looking the other way. And I think at this point we're going to do a deft change so that David can show you our latest progress visitors videos, and I'll be back with you in a few minutes.
Lots of the guys came back with a ready-to-go attitude, just want to get on and build it. They take pride in their work and they like seeing progress.
We're towing TBM Selena up the Thames.
It's a really special day for Tideway.
Today's been quite a big day for the Frogmore Connection Tunnel. Yesterday we broke through into the Harnworth Road shaft, completing our 1060 ring journey. And today we're cleaning up the head, ready to start shunting it more into the shaft of Harnworth.
So we've been planning this moment for about 3 years now, so it's finally the end of tunnelling for the Frogmore team. So this tunnel is capturing all the wastewater from the Wandsworth town area, and we're diverting it down into Harnworth Road. We did have a few problems over the last month, especially since we restarted after COVID. Things were a lot slower. We couldn't bring the full gang, obviously due to COVID reasons, so we had to keep it as sort of a skeleton crew.
I'll kind of give you a bit of an overview of how we excavate and how we build the tunnel. So you can see here, these are concrete segments. So they come in on a train and they can be picked up. We've got a kind of robotic arm that will pick them up and place them in position. The breakthrough brought a mixture of emotions, relief as we saw the nose cone come through where we wanted it to, happiness that we've come together as a team and finished the project. Also a bit sad that the gang's going to disappear fairly soon. We work in 2 different shifts, so we've got day shift and night shift alternating, and so you build up some rapport, some respect, and have a lot of fun together.
Behind us today, we're towing TBM Selena up the Thames to her drive site at Chambers Wharf in Bermondsey. This is the culmination of many years' worth of planning and a lot of hard work by a number of contractors and by Tideway themselves to make this happen.
Today's a really special day. It's taken a lot of people a lot of time to plan this operation. As you can see, it's gone very smoothly so far, and to showcase it to the public in London is a really special day for Tideway. So right now we're more in the TBM and Skylift 3000 alongside Chambers Wharf's cofferdam. This TBM weighs around 900 tonnes with its cradle. It's just under 9 metre diameter.
The significance of what we're doing behind me, this is a jack-up barge that can lift 3,000 tonnes. We're going to be lifting the TBM out of the river and driving it off. We'll sit there for a couple of weeks, but we will start tunnelling in about 2-3 months' time. It's the first time this has ever been done with a tunnel boring machine in the United Kingdom.
Literally, I mean, words can't describe how big it is.
Everything worked very smoothly. There was no hiccups. Went exactly as planned.
Acton here is the breakthrough site for the main Western Tunnel drive. We started the drive in May 19 and here we are in September 20, end of the drive.
The breakthrough is happening as I speak, just behind me. So far, from the latest I've seen, we can see approximately half of the tunnel boring machine. It looks like it's in the right place, which is great. So far, so good. This is the first mainline tunnel breakthrough on the project, and this is a milestone we've been looking towards and planning towards since we started almost 3 years ago now. So yeah, fantastic milestone. Feels great.
Amazing, literally hard work paid off. Thanks to everyone working within the main tunnel team, Acton team, Cardiff Road team. Yeah, it's just been a great collective effort.
We are floating the culvert that we have been building inside the cofferdam. We are going to put this culvert in front of the fleet, and it's a great piece of engineering.
Today we have floated, after 4 years of design and engineering, a culvert structure. It's about 3,700 tonnes, and we've done the first initial move, so that's the 10-metre move. It is momentous because it allows us to make the big connection to the big CSO under Blackfriars Bridge, and we'll be completing this operation a little bit later, about 12 hours later, once the next tide comes up.
It's going to be a huge transformation to the site once we get this culvert into its final position. We're all very excited about getting it done tonight.
Well, we are waiting now, anytime now, so in the next 10 to 15 minutes, the culvert is beginning to float. Then we are going to be waiting to the tide to float a bit more in order to have a bit more water under the keel.
Great achievement. Everything worked very smoothly. There was no hiccups. Went exactly as planned.
Literally.
Okay, so just a final few slides. Tower Bridge, which we passed underneath, right between the two piers, about 50 metres depth, about 10 days ago, very successfully. Huge amount of instrumentation on Tower Bridge. If you go to the next slide, you can see the position a few days ago of our tunnel boring machine there underneath the bridge, and the other one actually is there at the shaft at Cardiff Road, just ahead of it, waiting to go to the right, up and underneath the River Thames to complete its journey. So actually, Chambers Wharf, which is in Bermondsey there, there's the tunnel boring machine comes in from Greenwich, another one goes out to Abbey Mills, and the one there that's gone under Tower Bridge is coming in to Chambers Wharf in the next few weeks. So I think that pretty much reaches the end of my presentation. And David, I have looked at the questions, some of the questions as we've been showing those videos, so I could probably answer some of them fairly quickly. Right away, and then we could go on to any more that come in. I don't know how you'd like to do that, or Rimesh.
Yeah, that's right, Roger. Just we can work our way from the top, and whichever you prefer, you can just start answering them. Go for it.
Okay. So maintenance. Someone's asked about maintenance of the system. really what we've designed it for is to last for that time, 120-year design life, and to be pretty much maintenance free. Once the tunnel has been fully commissioned and trialed and everybody's accepted, it goes into final full service. We really don't want to put anybody down there. There is no mechanical electrical equipment below about 10 or 15 meters anywhere in the system. So once you get into the deep shafts and the tunnels, it's got nothing in there to maintain other than the reinforced concrete of the actual shafts and tunnels themselves. We do a good job in the construction of it, which that's what we're intending to do, and we inspect it fairly infrequently, like maybe once every 10 years, and we do not expect to have to do maintenance on it over its life. We will hopefully be doing the inspection remotely. We've got quite a lot of research projects underway to look at how we would inspect the tunnel system without people going down there. We may have to do one system with people down there, or one inspection, but then after that we're hoping to use a combination of drones and sort of Mars rover type vehicles, which are autonomous vehicles that can go up and down the tunnel, and really we are strongly trying to avoid having any maintenance required in the first place, and secondly sort of being done by any humans. On fatbergs, I think and on the old sewer, the old sewer system, I mean, this doesn't replace the old sewer system. It basically replaces the river. So the old sewer system carries on working, does what it's always done. When it gets full, it doesn't overflow to the river anymore, or it overflows to our tunnel. But everything else in the old sewer system is largely the same. We're not really changing it. We are providing a 1.6 million cubic meter effective replacement for the Thames. So instead of that sewage overwhelming the old system and going into the river, it overwhelms the old system, but it goes into our tunnel. And that's so generally fatbergs don't end up in the river. Very, very occasionally you end up with something like that getting in there, but generally the fatbergs are things that are found further up the system, closer to the places that are causing the problems, so closer to Chinatown, Soho, where the restaurants are pouring out that stuff. By the time it gets to the CSOs, there's generally not so much fat and fatbergs. They tend to sort of congeal further up the system. Someone made a question about boats and the air quality. Yeah, there's two or three things we've done. I mean, it is much more, much better environmentally to move material in a barge with a modern tug pulling or pushing it than it is to take it onto a truck onto the street, onto roads. And I haven't got the figures immediately off the top of my head, but I think we've done a lot of testing for both the sort of the greenhouse gas emissions, so the carbon footprint, and also air quality, and in both cases a dramatic improvement by using barges to take materials out. The materials, there's around about 4 to 5 million tons of material that's going out by river, and that goes onto the barges, and it will go down to places like Rainham, Ingerbourne Valley, down on the by river, and taken off onto jetties and used mainly as sort of capping for landfill sites, daily capping, and then final capping for landfill sites down there. So it's a good environmentally friendly outcome for that. Someone asked about the capacity lifetime. Well, the reason why the problem has got worse in the last few years is because of climate change, because there's been more intense rainfall, heavier rainfall, and also because people have paved over their gardens and whatever in the London area. So so instead of the rainfall seeping away, it goes directly into the sewers. Now, there was a solution that you could replumb London and not do it like this, and do it by as somebody mentioned in the Q&A there, separate the system back out. But that would have meant sort of works to sort of every house, every street in London, probably taken 20 years and cost £20 billion. So it was ruled out on the basis that it would take too much time, too much disruption, and cost too much money. So that's why I went for the solution that we've got. It depends on, if you take the climate change predictions that the government was asking infrastructure owners to follow a few years ago. In my recollection, by about 2070, the assumption was that the human race has got its act together and the climate change is on the way down. So the excess rainfall and sort of dramatic sort of climate change conditions are starting to abate as you get to sort of 2100. And so the actual requirement for the tunnel starts to ease off into the future, because it's largely driven by a combination of climate and the population of London. As the population of London goes up, so the capacity of those low-level sewers to take storm flow goes down, because you've got a higher underlying level. So at some point in the 150 years, when the population is 16 million, if it ever gets there, there'll probably have to be some dramatic changes anyway. But certainly in the current sort of next 50 to 100 years, it is future-proofed. Somebody asked about the TBMs and what's happening to tunnel boring machines. Yes, they're all being reused. One of them is the shell of it is parked up underneath Fulham. That's its resting place. But everything inside it, all the kit, all the equipment, the bearings, the rams, the hydraulics, all taken out. And the other tunnel boring machines will all be lifted back out of the shafts and taken back to the manufacturers and reused in other schemes. Somebody mentioned about what's the effect of the river from all the work where all of the structures we're putting into the river. Very good question. A huge amount of work was done to minimize the footprint of those structures in the river by designing the size of the shafts to be as small as possible. One of the most trickiest parts of the river was at Blackfriars. Blackfriars is quite a narrow part of the river, and to put our structure there was something that required an awful lot of interaction with the Port of London Authority, the Environment Agency, and other agencies like the MMO, Marine Management Organisation. A huge amount of scour and accretion modelling was done, and that will carry on to being done sort of into the future, to make sure that the way that the river sort of responds to that in terms of where it does scour, where it does have accretion, is followed. So we've got an obligation to do that, but the modelling that we've done shows that it's sustainable. Just make sure, Ramesh, I haven't.
No, I think you've been going through the list very well.
So the vortex generator. The purpose of the vortex generator is to entrain air into the fluid, so that when it gets to the bottom, it's nice and soft, so it doesn't create too much cavitation and damage to the bottom of the shaft, because you are dropping it 50 meters, but you entrain the air in, and probably you don't want entrained air in the deep tunnel. So the bottom of that vortex generator, bottom of the shaft, where you've got that wall that you saw in that slide, that allows the water to sort of still, the air to come out of it before it flows down into the main tunnel, because we don't want large pockets of air in the main tunnel. So it's an interesting hydraulic balance between entraining air to make it a safer means of dropping the flows through that height, but not having so much air that it gets into the tunnel and causes pockets of air that can then move around and cause some of the sort of those problems I mentioned before. Somebody mentioned about the spoil getting to the end site without clogging up London's traffic. Well, I think I answered that maybe through the about the amount of material we're putting out onto the river. We're not using trucks, we're using the river significantly. So pretty much all of our spoil is going out by river. I think I've asked about when the spoil go to. I've asked that question. Why is mental health such an issue in the construction industry? Well, that's a good question, and I think it's because a lot of the construction industry, people are working away from home. A lot of the construction industry working long hours. Some elements of the construction industry is self-employed or 0 hours contract. On a big project like Thames Tideway Tunnel, we have lots of requirements of our contractors and their subcontractors, and we monitor that very carefully. So we really are very close to everybody working on the project, and indeed people who most clients wouldn't really consider, like the lorry drivers delivering equipment to our sites. If you make more than 3 deliveries to a Tideway site, you need to go to our project induction centre and spend a day on induction, which is unheard of. But we did that because we realised we're a big project and we want to make sure that anything that's delivered to our site, that the people who are delivering it understand about the project, feel some ownership, feel they're part of something bigger, and feel pride in being part of what we're part of, and therefore take a bit of extra care about what they're doing. And so far it seems to be making a difference. But coming back to the mental health issue, I think people away from home, and some of the employment practices, maybe not of a project like ours, but generally out there. And what we wanted to make sure was that on our project that we were seen as a shining light of this sort of thing. We've also done things like we've got a very strong and positive occupational health provision with nurses and occupational health professionals doing tests, doing screening for people, being there for people, because often it's linked together. If you're working away from home, your GP's in Sunderland and you're in London, you feel something funny, you don't go to the doctor. Well, we want somebody to be able to walk out of their site and then go and see the nurse and just talk to her about it on the way home, and that catches it. And I know from talking to occupational health sort of professionals on the project, somebody's told me he thinks he's saved 3 lives just in his own experience by picking up an arrhythmic heartbeat on a very sort of fit and well and healthy young woman, and also a chap who was a bit older with serious blood pressure issues that hadn't really properly got it addressed. And in both these cases, he picked up through a sort of routine screening an issue which, if it hadn't been picked up, could have led to their deaths. So that sort of thing is where I think we as a client have felt we want our workforce to leave this site, this project, healthier than when they arrived. And it's not just the right thing to do, it actually makes business sense as well.
Right, thanks, Roger. We've just had I think another one of Len's questions that has been upvoted is, I guess, the hindsight question. What is it that you've learned now before you started? What's the main lessons learned?
What we do differently. I think one thing we do differently. So in some parts of our site, I mean, the sites are in central London. We did a lot of site investigation before we started. There were 1 or 2 sites where, because of the sensitivities of local residents. We didn't do quite as much site investigation and invasive digging around as we wanted to. And one or two of these sites, that lack of doing it in advance has then caused us to find things that were quite unforeseen and quite significant, and have resulted in some quite significant cost and time overruns on one or two of our sites. So I think if we had a time again, we'd have probably tried to have done that. But at the time, when you're going you're trying to get your project through the planning phase, you know, this is a very impactful project in London, affecting hundreds of thousands of people. And we made a call then that it was better to sort of not to go into this area and do more site investigation. Had we done that, we might have stirred up a hornet's nest. We might have got more objection, and that might have affected our planning application. We just don't know. So, but I would say that in the end of the day, it would have been the right thing to have done, because that site has gone on for longer, because we've had to deal with something that if we'd known about it a bit earlier, we could have avoided some of that impact. Not all of it, but some of it.
Right. I've got a question for you, Roger, that came in there, which was, you mentioned telemetry to control the system. And the question is, how much telemetry is there? And apart from the pumps, what equipment is there?
So in terms of mechanical equipment, on each site there are penstocks, hydraulically and electrically activated penstocks. So the large cast iron gates that will come down to close off the flow into the tunnel. The tunnel is basically open all the time, and it's always open. It closes when it starts to fill up at certain levels. So you've got the penstocks. There are secondary isolation gates, but they're mechanically operated. Cranes lower those gates in. You've then got quite a lot of monitoring equipment, monitoring sort of the level of water in the structures, the interception structures and the shafts, so that you know how the tunnel is filling, where it's filling, that sort of thing. So there's quite a lot of sort of instrumentation of water level. There's the an air ventilation system. So the tunnel is, when it's empty, which it'll be empty for 90% of the time, or more than 90% of the time. So just, you know, despite how London feels sometimes, actually the rainfall is generally not enough to have the tunnel being filled up more than sort of that sort of amount of time. So most of the time it's empty, and during that time the air is changed pretty much every day. So there are 4 or 5 sort of active management sites across the project in the west and in the east, and they basically force air in, suck air out to make sure that the air is fresh inside the tunnel. It's not building up sort of gases. The most important gas to avoid for us is hydrogen sulfide, which floats up to the top of the shafts and then can cause corrosion to the concrete up there. So that's the main thing we're trying to keep out of the tunnel. So you've got that system, and then what you have is a sort of, most of the sites have a passive ventilation system, so that as flows come in, air comes out, it goes through a carbon layer and it goes up through those ventilation columns you saw, which are anything between 4 and 15 meters high. And then you'll have the sort of the telemetry system which links back to the control room in Acton, where the operators will be monitoring the system. So it's relatively simple, you know, and all of that stuff is contained in the near ground structures, and there is nothing at depth whatsoever. So nobody needs to go down into the tunnel to maintain a piece of telemetry or anything. It's basically just an empty structure. Does that answer your question, David?
I think that's answered probably 3 or 4 of the questions. That's excellent. Thank you. There was another question, I think, was how do you avoid the overspend problems? I think, were they mentioning HS2? But that sort of question, how have you managed to keep the project on track?
I think I've been on the project for since 2012, and I think we're very lucky that we've always said had a good support from a whole load of stakeholders. So Ofwat, Thames Water, obviously, who started the project off, DEFRA, the Environment Agency, government generally. Everybody wanted to see this project be a success, and I think we've had a good group of senior folks from those stakeholders and involved at the beginning, and then our shareholders, the new company came in. They also were taking a very long-term view. So I think we've had lots of continuity of sort of the ethos of this project all the way through it, which is helpful. So you haven't got projects that have been passed from one group to another group, and you've got sort of discontinuities as they go through. And I think we've had people involved who really understood the project on the government side, and you know, when we looked at risks and costs and how we're going to go about it, I think we started off with a good budget at the very beginning, and we've, you know, a good approach to risk and reasonable levels of contingency in there. And you know, as you know, you probably know we've gone back twice to say, actually, our budget, we've gone over our budget. It's going to cost more. So we announced, I think, 280 million a couple of years ago, and we had some of those problems caused by the site investigation issues I mentioned. And also we decided to put more material by river. We made a decision to do that. That cost us more money, but that was what we thought was the right thing to do to get more trucks off the roads. And then obviously we've been affected in the last 8 months by COVID, and that's £233 million impact and 9 months on our handover date. But the good thing about that is that despite those increases, we are still at the same level of bill impact as we expected to be in the first place, which is £20 to £25. And our whole delivery model is very robust, I think, in terms of providing a good sort of cost efficient outcome for bill payers. So despite that, we're still not going to threaten that £20 to £25 range.
That's good. Thanks, Roger. There was one more question actually about the public usage and how once the project's handed off to the London system, what benefits and what can we look forward to in terms of recreational uses or community day outs and, you know, those sort of activities?
So I think in a lot of recreation happens in the west, but also quite a lot happens around the Isle of Dogs and in the east too. I think we've seen the Lee River clean up very, very quickly since the Thames Water put the Lee Tunnel in place. Over in America, in Portland, in Oregon, very similar system, a lot smaller, but very similar. A dramatic change to their river environment and a huge sort of reconnection between the Portland public and their river. And I think we'll see that happening in West London. With, you know, there's a huge amount of rowing that goes on in West London, but they have to be very careful about when they do it because of the weather. You know, we had a massive event planned last September 2019, Regatta London. We had to cancel that because of sewage in the river following big storms that happened. So that will, I think, that will dramatically improve that side of it and attract more people onto the river once we've seen that happen in other parts of the world.
That's good.
I think I've got one more question here, which is, will there be bad smells coming out of the ventilation system?
No. The 99.9% of the air that vents out of the tunnel will be treated through the carbon filter system. And the only time where momentarily there won't be treatment is when the tunnel is filling rapidly, and in order to protect the carbon filters, if the pressure builds up beyond a certain amount, there's a sort of bypass flat valve that opens. So if you're standing near that place, momentarily in a storm, you might get slightly bigger whiff. But to be honest with you, we've got the systems in there. We'd be very surprised if there are any complaints from odour, and it's something between ourselves and Thames Water we've looked at, and this system will have the highest level of odour sort of odour management on any system of its kind in the world by a significant amount.
Okay, that's excellent. I think we'll probably draw it to a close now, because we've answered, I think, most of the questions, and you've been speaking for a very long time, Roger. Now, normally at this stage, of course, we'd all join in a huge round of applause and say thank you very much, but only Ramesh and myself could probably do that. So thank you very much, Roger, for that. And we've still got over 200 people on the call, so hopefully they've all appreciating this. So thank you very much. It's really fantastic that you've given up your time to do this. What I'd just like to do is share just some final information. Just as I mentioned a bit earlier, you can record your 1-hour CPD, continuing professional development points. There's a form you can download from the IET community that's there. I also put it on the chat, so you can get that before you go. And just to let you know, as I mentioned, we have run a few of these seminar lectures, now webinars, until we can get back to our normal home in Savoy Place. So on Wednesday, 9th of December, oops, sorry, that's didn't expect to go up there. Emergency on Planet Earth, Dr. Emily Grossman, who's an honorary STEM ambassador, internationally renowned, very popular, and that should be a fantastic talk. So please sign up when you can, and then we'll have a panel discussion in January. And if you want to get involved, please do continue the debate via Twitter or Facebook. So thank you very much. And thank you to us. Please provide your feedback. You'll get an email from the IET asking for your feedback on various topics to do with this event. So please do, and that would be fantastic. So I think it just remains to thank everyone for joining again. Thank you very much, Roger. And I don't know if you've got any last words. And we look forward to the next one. Thank you, Ramesh, for helping.
Okay, thank you, David. Thank you, Ramesh. Cheerio. Have a good evening.
Thank you. Bye.